So we go to these highest mountains on the earth, like Huascaran here. And even though that's in the tropics at 9 degrees south of the equator, if you go up to 20,000 feet, you're really going into the polar regions, and that history is preserved there. And by acquiring these records from different places on the planet, we can put together a global picture of how the system has been linked through thousands and thousands of years. And if you look at that history, you can see that during periods when the Earth was in an ice age, CO2 was 180, 190 parts per million by volume. And during warm periods when the glaciers melted back, CO2 was about 300 parts per million by volume. Today, just last year, we crossed 400 parts per million by volume. And we have not seen that in the 800,000 year history that's recorded in the ice. And in fact, if you want to find similar CO2 levels, you've got to go back 2 to 3 million years. And if you go back 2 or 3 million years, temperatures were 2 to 3 degrees warmer for the Earth, and sea level was 25 meters higher. So by studying the past, we can really put the 21st century into a perspective. So in a glacier, you can find histories of temperature, precipitation, in the layer thicknesses in the ice. You can look at volcanic eruptions in the tephra and the aerosols like sulfates that are recorded there. It's the only place that we can get a history of the greenhouse gases, CO2, methane, nitrous oxide, because in the ice there are capsules of air that capture the atmosphere. And we can remove those air bubbles and determine how those gases have changed through time. If you look at our instrumental records, they only go back about 132 years. But ice cores can take us back year by year for thousands of years. And if we do that in this part of the world, we find that there are two major events that have occurred. One from 1789 to 1800. This is a huge drought that impacted this part of the world. And in this region that we are now setting in Bangalore, it was particularly hard hit. In 1792, 600,000 people in this area starved to death because of the failures of monsoons at that time. Well, that event is recorded at the top of the Himalayas in the chemistry, in the ice cores, as a major drought. And it's more unusual than anything that we've seen in the last 250 years. And if we go back further in time, we come to another event, which is from 1345 to 1370. Impacted this part of the world, but also impacted the other side of the Pacific, over in the Andes, where we also have ice core records. Both of these events stand out as very unusual and extreme. And during the 1345 to 1370 event, this is the time of the plague, where we lost over 30% of the world's population. And the climate connection lies in the fact that the bacterium that causes plague is always present in the soils. But for some reason, in this period of time, it was able to be transported from the soil to lice, and from lice to fleas, and fleas to rats, and from rats to human beings. And why, understanding why the climate at that time, or what role the climate at that time played in allowing this to happen, becomes extremely, extremely important. Ice cores, we believe, are our best recorder, but we have trees, and we have speleothem cave deposits that can also give us records of the past, lakes and marine cores to put together this picture. And if you look at these two events, you find out that they show up in cave records here in India. They also show up in lake records in Indonesia. So there's a lot of indication that these are very unusual, and when these events occur, there's major disruptions in cultures around the world. And we believe they point to El Niños, big INSO events that are much greater than anything that we've seen in the last 132 years in this part of the world. If you look closely at these, you can actually see the annual layers. So they record very much like a tree ring does. In these cores from the low latitudes, we find insects perfectly preserved that can be identified and dated. There are plant fragments in the cores that can be carbon-14 dated. And there's even bacteria and viruses that's in the ice that can be identified. And you can look at how these have changed through time in this frozen history from the past. So really anything that's in the atmosphere gets recorded. So we can look at the growth in pollution in the atmosphere. We can look at black carbon, which is a very important factor in this part of the world, and how does black carbon impact the melting of the glaciers in the Himalayas is an area of current research. This is a view looking at the top of Kilimanjaro in Africa, the highest mountain in Africa. And the glacier in the foreground is the Furtwanger. And we drilled ice cores from this glacier back in 2000. And as of this past year, in 2013, 13 years later, the drill site is no longer, the ice is no longer there. And what's happening on Kilimanjaro is indicative that's what's happening to glaciers throughout the world. In all the mountain ranges, whether you're in Africa or South America or here in the Himalayas. And the unfortunate part about the loss of the glaciers is that you're actually losing the history that's recorded in the ice. And so there is an urgency to recover these histories before they are lost. Because even if the climate changes, once it gets colder again and glaciers start growing, whatever that history that was there will be lost and a new history would grow. In fact, the latest Intergovernmental Panel on Climate Change that just came out last month indicates that should temperatures rise by 1.8 degrees C by 2100, we'll lose 48% of the area of glaciers in the Himalayas. And should we follow the business as usual model, which we're currently on, temperatures will rise 3.7 degrees C. And in that case, we'll lose 68% of the glaciers by 2100. So these are natural dams, they're natural water towers, if you like, that have stored water for thousands of years, and today we're losing them. And they have serious geopolitical implications, because if you take the Indus River, it flows through 3 nuclear-powered countries, China, Pakistan, and India, all of which depend on the waters in that river. So what's happening to the glaciers has a real impact on the people who live downstream. Here in India, but also in South America or in any part of the world where we have water resources that are dependent in part on the presence of glaciers. One of the unique things about our program is that we go to the parts of the world that people haven't gone before to recover ice cores. And there's always a challenge of working in extreme environments. High elevations, you get above 20,000 feet, you have over half the atmosphere below you. So there's not a lot of oxygen at those elevations. Usually there's very cold and high winds. And often you're at the end of the food chain, and that food has to move from the base of the mountain up to where you're drilling. So it's a challenging environment to actually recover these histories. But when you're there drilling, there's a lot of excitement, because every time you send the drill down, you're going to bring up a record that nobody has ever seen for that part of the world. And there's always a lot of excitement when you hit bedrock and you bring up rock from the bottom of the glacier. It's a challenging environment in which to work, but our teams are international. We usually have Russians and Chinese and Americans and Nepalese and South Americans all working on one expedition. And we can all work together to accomplish that goal. And that gives me great optimism about the future, when we all have to work together to find solutions to climate change that will impact all of us.